This is the ROS Developers Podcast, episode 43.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome once again to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez here from The Construct, and today I'm in a very special location. Actually, I'm at the airport Charles de Gaulle in Paris, because I am traveling to China to do a series of conferences and speeches there at the universities and some companies also. And so I didn't have the time to record the episode before, and then now while I'm waiting for the flight, so I decided that it's a good moment. I have tried to minimize the noise of the environment, and I have done several checks and tried to cover the mic, etc. And I hope that the quality is good enough. Okay, so what is the episode about today? Well, that's a question. It's a question that I get many times. So it's how should I start with ROS? So what should be my path in order to learn ROS and then be up to speed as fast as possible? So we have written many articles about that. We have already spoken at several places, but I thought that answering this question here in the podcast could be very useful for the people, because you can listen to it while you are doing some other things. Then today the podcast is quite special because there is no interview to somebody else, but I'm going to provide you with a set of steps that you have to do in order to get introduced into ROS and how to move as fast as possible. And before we start discussing about which are the steps, I think that there are some questions that need to be answered before. For example, one of the questions is that it's important to answer before is, do I have to use ROS for Linux, for Windows, or for Mac? So that's the first thing that you have to decide, which one you are going to use. Then, of course, my recommendation will be to use ROS or Linux. And why? Well, because ROS in Linux was the first option that appeared. So ROS in Linux is the more mature ROS version. Mac is the second version of ROS that appeared. So I mean the support of ROS for Mac, but still is a quite difficult way of installing it, and especially maintaining it and solving errors. So I still will vote between ROS for Linux or for Mac. I still will vote for Linux. Then there is recently it has appeared ROS for Windows that has been developed by many people, but mainly by Microsoft now. And then, of course, if you are a newcomer to ROS, I don't recommend you that you start using ROS for Windows, even if you may be attracted to it because you know Windows and you don't know Linux. I think that you need a lot of ROS knowledge in order to install and use ROS for Windows. So you are starting, so it's not your position there. ROS for Windows, it's a good line that is going to evolve in the next month, in the next years, but I think that is too early now before you can get something useful for if you are a newcomer to ROS, okay? So my recommendation is start with ROS for Linux, and especially ROS for Ubuntu, because it's the simplest option. Then another reason why ROS for Linux to use ROS for Linux would be that the most of the robots that you can buy that are shipping with ROS on board of the shelf, they are running already with Linux. So if you buy one of those robots, or you are going to work with one of them, you are going to need to use Linux anyway. Then a second question that I usually get is, okay, so I'm going to start with ROS, but I heard that there is ROS 2 on its way, and what should I do? Should I start with ROS 1 and then move to ROS 2, or start directly to ROS 2? Okay, if you are a newcomer, then just very clear answer. Go straight to ROS 1. Yes, I know ROS 2 is the future. ROS 1 versions, it's very likely that they will end in 2020, but still, learning from scratch ROS 2 is going to be very difficult. The documentation that exists is not complete. I mean, it requires a lot more of work from your side if you want to start with ROS 2. So I highly recommend you that you start with ROS 1, because most of the concepts of ROS 2, they do exist on ROS 1. So it's going to be easier for you afterwards to switch from ROS 1 to ROS 2. Then final question before we start with the path is the third question. It's okay, so ROS can be programmed by using C++ and Python mainly. There are other languages, of course, but those are minor. So let's say C++ or Python, which one should I use? And then this question, the answer for that is it depends on your knowledge. I have been doing many courses at universities and about ROS, about teaching about ROS, and then I seen that it's most of the people that came to those courses, they didn't know neither C++ or Python. If that is your case, then very clear answer, start with ROS with Python. If that is your case, you don't know C++, neither Python, then start with Python directly. Then in case that you know C++, well, it depends. It depends on what you would like to do. Developing or learning ROS with C++ is more difficult than learning with Python. And also it's slower. It's slower because you are going to have a lot of problems in compilation time that you are going to need to solve them, even if they are not related to ROS. Just because C++ has this effect, this that you need to compile, and then many errors appear there. So then it depends. So if you are you know C++ and you are aiming to work for the industry, then go for ROS for C++, because C++ is the language that is used at the industry in robotics mainly. Then the other way, if you know C++, but you would like to work on research on an institute or at a university, doing your PhD, something like that, then go for Python anyway. It's going to simplify for you a lot your life, really. You are going to move a lot faster. And at the end, in research, you need to publish as soon as possible. So Python is going to serve you better. So ROS for Python is easier, and ROS for C++ is let's say more powerful. So, but there is the election. Okay, I think I have clarified the options that you have, and then you must decide by yourself. And another related question is, okay, but what about Python 2 or Python 3? Then yes, so my recommendation will be to use Python 3, because I know that the current versions of ROS 1 are based on Python 2, but the next one is going to be based on Python 3, and Python 2 is going to disappear in the short term. And there is no so many differences between Python 3 and Python 2 while learning ROS, I mean, that you cannot overcome. So start learning Python 3 and then just adapt to Python 2 when required. Okay, so those are the questions that you need to have clarified before you start learning ROS. Now, what do we have now? So now let's see about the path that you should do in order to learn ROS. So what is my recommendation? Okay, based on my experience, I have taught many courses to many students, either online or at the university also. So that is based on my experience. I don't have all the knowledge of the world, but I think that my experience can help you to move faster. Then my recommendation is, the first step is that you need to learn Python and how to manage the Linux terminal. Okay, we have indicated, okay, you need to learn Linux because you are going to use Linux. So you need to go and first of all learn how the Linux terminal works. You need to know how to create folders, how to move between different folders, how to remove files, etc. How to open process, how to get the list of processes, etc. So that is basic. And then you have to learn how to program in Python. So I assume that you are going to use ROS for Python. In case that you know C++, then you can skip this step about learning Python because you already know C++. I definitely do not recommend that you start learning ROS at the same time that you learn how to do C++, how to program in C++. Definitely don't try that. Don't try. Yes, I know that you can do it. Okay, so I'm not telling you that you can do it. You cannot. I'm not telling you that you cannot do it. But the thing is that I'm talking here about an optimal path for learning ROS. Okay, so that is going to take you a longer time. Okay, so you know now Python and how to manage the Linux terminal. Then you should start learning the basics of ROS using simulations. So you have to use, you have to find simulations that already exist and just open them, launch them, and use those simulations of robots in order to learn the basic concepts of ROS. Which ones are those basic concepts? Okay, so those basic concepts are how to read data from sensors. For example, how to read the data from a laser. So how to do that? Okay, I'm not going to tell you technical terms here. That's how to read from a topic. Okay, but that makes no sense here because you don't know what is the topic. So if I mention that, you don't. It makes no sense. But it is very clear for everyone the concept about how to read data from sensors. Okay, so go and check how to do that with ROS. Then another thing that you need to learn in the basics, how to send commands to actuator. For example, how to move a wheel, the wheel of a robot. Another thing, basic thing, is how to organize the different robot functions, so the different things that the robot has to do, into different ROS programs. And those ROS programs, they must interact between them and interchange information. So how do you organize a whole list of ROS programs in your robot so they share information between them and collaborate in order to make the robot do what it has to do? For example, you use a wheeled robot simulation with that the robot has a laser on it, like for example that of the Turtlebot. And then you create a ROS program that reads this laser and computes based on this laser lecture which is the direction that has the less obstacles in the path. Then there is another ROS program inside the robot also that is running at the same time as the first one. Okay, so they are running in parallel, different ROS programs running in parallel inside the robot. So this second ROS program is calling the first one, asking for, hey, please tell me, what are you seeing? Which one is the safest direction? And then the other one answers with the computed direction, and then the second program has to compute the speeds of the wheels required to move the robot towards the safest direction. So that's, for example, one example of several programs of ROS programs that are running on the robot, each one doing different things but collaborating in order to make the robot reach the goal. That is, just do not crash, for example. Okay, so that will be about learning the basics of the ROS. And for that, again, use simulations of robots. Do not use conceptual programs. Like, so that's how a program of ROS will work, reading from a laser, but we don't have a laser here, so we are going to imagine that there is something that is getting the laser data, putting the laser data. Okay, yes, that's a lot more abstract, and it's a lot more difficult to understand. And the concepts of ROS already are complex, so you have to simplify. If you can see that coming from the robot, even if it is a simulation, then your brain is going to understand very clearly how that works, and you are going to move a lot faster. Okay, so once you have mastered the previous concepts, then I would recommend you that you do the same exercises that you have done, but with a real robot. Instead of using a simulation, you get a real robot. You can buy the robot or rent it, and it has to be one robot that already has ROS in it. There are many companies there on the outside that they sell robots based on ROS, so that you switch them on and they are talking ROS there. So, for example, you can buy the Turtlebot robot, and it's running ROS off the shelf, so you don't have to do anything. You just buy, switch it on, running ROS, and then use that robot to create again the program. Well, actually, to run those programs that you have created inside the robot. You will see that there are a lot more things to learn with the real robot, that things that you are not able to actually reproduce where you have done in the simulation, and you need to modify and take into account many other concepts of ROS. Okay, but you are moving not from zero, but from a situation where already was working for you, that is in the simulation. Okay, so now once you have mastered the previous concepts in the real robot, then move to learn the ROS navigation stack. Navigation means making the robot be able to move by itself on an environment, okay, while avoiding obstacles and while going from one point to another one. Yeah, I know that this is here. It's strange that they are doing some announcements here, but yeah, okay, they stop. Great. So yeah, so navigation allows you to make the robot move by itself from one point to another while avoiding obstacles, and that's a basic skill for robotics. So you have to master that. So again, start using the simulation first to learn how the ROS navigation stack works. The ROS navigation stack is the set of programs of ROS code that is already done by ROS, that you need to learn how to use them inside your robot to make a robot navigate. So that's it. Then use it on the simulation first, and then once you have it running, move to the real robot. But please don't do it the other way around. Okay, it will be a lot more difficult and more time in order to learn. And remember that you have to practice. Okay, practice is the key. You don't have to to read documents or watch videos and say, okay, I understand. No, that doesn't work. It's not when you need it. Those skills, they are not going to work for you. So you have to apply. You have to practice. And practice with robots, of course, as I mentioned before, either if they are simulated or real, but do it. So don't use toy examples.
Okay, so I finally have to switch place. Actually, I had to stop recording the episode and then move to the plane because it was my call for the plane. So I had to move, and now I'm back at the hotel, and then I'm already arrived to China and recording the rest of the episode in the hotel room. So I think that the quality of the sound is very good. So let's continue with the steps that we had in order to learn fast ROS. So the point that I left the podcast previously was when you have already mastered navigation for ROS. So you have mastered the basic concepts of ROS. You have mastered how to do navigation, how to use the ROS navigation stack with a simulated robot and also with a real robot. Okay, so now at this point, it's at this point that I think that is the proper point to start learning ROS for CPP. So in case that you started learning ROS with Python, which I recommended at the beginning, then now is the point where you can try to switch to C++. It depends, okay? So it depends in how you feel. If you feel comfortable with Python, you don't think that you are going to need CPP, then just keep doing it with Python. You are going to be fine. You're going to be able to do almost everything in ROS using Python, almost. But if it is your situation that you wanted to, from the very beginning, you wanted to do ROS with CPP, C++, then it's the moment here. So what do you have to do at this point is to come back to the beginning of ROS Basics and learn again all the basic concepts of ROS by using CPP. You will see that there are many other concepts that are hidden when you are using ROS Python, are hidden by the system in order to make it simpler for you. And then you will have to learn about some additional ROS concepts that only exist when you use ROS in CPP. It's a little bit more complex, but now you are equipped in your mind with all the other ROS concepts that you have already mastered. And the strong point here about starting in Python is that if you start directly with CPP, you will have had to learn all those concepts at the same time. And I think that is too much. I think I think that you can do it. Okay, I'm not saying that you cannot do it. I think that it's like swallowing something that is bigger. So what I'm providing you here is a step-by-step that allows you to swallow small bites. And then by doing that, then you can go one, another, and then at the end, then you will have mastered everything, but in a more, from my point of view, of course, in a more faster way or optimal way. So if you want to learn ROS with CPP, this is the point. So go back, learn again ROS basic concepts with C++, and then continue. So now what is the moment now? So you have mastered ROS basic concepts, ROS navigation, and even on CPP. So now is the moment where you have to build your own wheel robot. And you need to build a robot that is controlled by ROS. So what I propose is that you build an Arduino based robot with a Raspberry Pi as the main ROS computer of the robot, and add a simple camera. So you will be building a differential drive robot and build all the ROS controllers that you need in order to control that robot from ROS. So you will need to control, for example, the motors using the Arduino board. So you have to send some commands to that Arduino board from the Raspberry Pi, and then you will have to learn how to do this in ROS, and also how to read the odometry or how to generate an odometry by reading the encoders of the robot. Also how to get data from the camera and publish into a topic. To a topic I mean publish in a way that ROS programs can get that information. And then that's the point because of this step. That's the point of this step because is when you are going to apply everything that you have learned into a robot that you are building from scratch. It's a simple wheel robot. Okay, I will put a link here beneath the podcast to a complete course that describes how to build that, how you can build that. And if you don't like this, you can search around the internet, and then you will see that there are many videos around that teach you how to build the physical robot and then how to put ROS inside. And then maybe you like to build robots, but maybe you are more into robotic arms, then do it. Then if you prefer to build a robot that is based on servos for controlling and for creating an arm, a robotic arm, so also go for it. It doesn't matter if it is a wheel robot or an arm robot. A wheel robot, from my point of view, is easier. It's easier to understand and is more applicable for doing experiments later than the robotic arm, but it depends on your taste. So go ahead to any of those. The important point here is that you learn how to relate the ROS concepts into a physical thing, into a physical robot. Because up to this point, everything has been kind of disassociated. So we have these ROS programs that are acting upon the robot, the physical robot or simulated robot. But how is this interaction meant to be? How does it work? So at this point is where you need to learn how. And then you will get the whole picture of ROS using in a robot. Then finally, another step, next step is when you have built this robot, then is when you can start learning how to apply ROS for other subjects. Like, for example, how to do perception with ROS, how to move robotic arms, and then how to do manipulation of objects. And you can apply all this to your built robot. So you can use this wheel robot that you have constructed to follow a line, for example, by using the camera. So you are going to learn how to apply other concepts that are perception concepts into the whole picture of ROS and physical robots. So that will be the next step once you have mastered all those other previous subjects. Then finally, the final point from my suggested list of topics is that if you want, this is for the case that you want to work at the industry. Okay, so in case that you would like to work for the industry, then you will have to learn how to do unit testing, how to apply unit testing to ROS programs, and how to work in a development environment using Git, Gtest, Jenkins, etc. So that will allow you to work with other developers and then to work together into a team that is developing without breaking anything. So this is mandatory. So I see that many people that come to the robotics world, they don't come from the computer science world. So in the computer science world, this is very clear. Everybody knows what are unit tests and how to use Jenkins, Git. But in my experience, the people who has come to our courses, even at the university, they don't know anything about that. They don't even think about those concepts, never heard about them. And if you are at the industry, those concepts are very important because they are providing robustness to everything that you build. Remember that you are at industry, so the products have to work 100% of the time. It's not just for the picture or for the video that you are going to build for your paper, for example. It's not a proof of concept. It is something that has to work. It's a product. You have to ship it to the client and then it has to work. And for that, some special requirements have to be met in order to make the code robust. So this is here how you have to learn how to integrate ROS, how to create tests for ROS programs. For example, one of the types of the test is to launch simulations that check that your navigation program is still working, even when somebody has modified the code. So you generate a system that automatically every Tuesday at 12, then it's going to launch a simulation of your robot and then launch your ROS navigation program and check if the robot is able to reach one point in the simulation, for example. And everything is automatically done. So you have to master how to build those tests, how to launch them, so how to program the system that is going to launch them, etc. And here is where I would finish the path to learning ROS. So I think that this is everything here. I have summarized the main procedures, the main steps that you need to master and the order for learning ROS in the optimal way. So I would like to know also your opinion about that. And please contact me. I will leave my contact details below this podcast, so you can contact me and give me your opinion. Also in the comments below this podcast, you can also put your opinion, and I will take care of answering your questions or opinions. And maybe with some of your experiences, we can even improve this procedure. I will be glad to hear about that. So that's all for today. Thank you very much for this special episode, especially in many ways, as you have seen. And that is all. And let me tell you, just before I finish, that we have launched the second edition of the ROS Developers Conference. The ROS Developers Conference is a hands-on conference. And what does it mean, a hands-on conference? It's a conference that you will not have just to attend and listen, but also you will have to practice at the same time as the speaker is explaining. So the speakers are going to come to the conference and they are going to show you, to teach you how to do something in ROS, something that they are experts in. And you are going to be practicing at the same time with him. And how can we do that? Okay, it's very interesting because it is an online conference. So the ROS Developers Conference is an online conference, and that means is that you don't have to travel. You're going to attend through internet, through a platform, through a link that we will provide to you, and then you only need to have a web browser, and that's all, any type of computer. So you will connect to that link, and then you will access the conference and all the material that we are going to release, all the code, all the simulations, all the notebooks with instructions, and you are going to open there the ROS code, the ROS notebooks that the speakers are providing, and you are going to use it for during the speech. So you will have to follow the instructions. You are going to learn a lot. It's the second edition of this conference. We had a lot of fun last year, and also we learned a lot because people is coming from different levels. The speakers are from different levels, so you can learn from things at the low level up to other things at a higher level. And you do it by practicing and asking questions to the speakers, and also to your colleagues that will be also online at the same time. So let me tell you that the web address for getting more information and registering to the conference is the rosdevcon.com. I'll put the link beneath this podcast. And that is all for today. So see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning, guys.